Hello everybody, we are going to be talking about our 2.2 notes today, which is the introduction to functions. Our learning target today is I can determine if a relation is a function given multiple representations and justify my thinking. We have three vocab words today. The first one is a function, and the vocab word for function is in a relation, there is at most one y value for every x value. And what I want you to think of is that we cannot have repeating x values. So no repeating x values. The next vocab word that we have is input. Your input is actually all x values in a relation. We've seen something like this before. If you have an x value, that's also known as domain. So if you see the word domain, x, or input, all of those are just referring to the x values in your relation, okay? And then output's going to be all of your y values. This was known as range. We talked about this in the last set of notes that we had, okay? So now you know domain, x, input, all mean the same thing, and then range, output, y, all mean the same thing. They're just your x values and your y values. All right, now let's talk about what a function is. I like to talk about functions as being like a vending machine, okay? So think about when you go up to a vending machine. You look at the vending machine, you say, I want that Snickers bar right there. And the first thing that you do is you put money into the machine. And the machine says, great, I got your money. So when you put the money in, that is your input, okay? So that is your money. Money goes into the machine. Then what you do is you type in the number of where that Snickers bar is located at. You're like, that is in slot A10, whatever it is, okay? You put the number in. That is your machine doing the work. That is the function itself doing the work. And then hopefully, if the machine is not broken, it spits out your Snickers bar, okay? So that is going to be your food. You input money, the machine does its thing, and it spits out food for you. That is how functions in mathematics work. You put something into the machine, into your function does its magic, its math, okay? And whenever you are done, you are going to have an output spit out, okay? Let's move on to determining if things represent functions, if relations represent functions. And the first one that we're going to talk about is a table. And we are going to determine if the tables below represent a function. If they do, great, we'll explain why. But whether or not they are a function, we are going to list the domain and range for these. So whenever we are looking at functions, we are only trying to look at the x values. And our goal is to ensure that we do not have repeating x values. If we have a repeating x value, we need to make sure that the y value is the same. If it is, we're good. It's a function. If we have repeating x values, but the y's are different, that's bad. So when you look at number 1, these are all of my x values. You've got 1, 2, 3, and 4. They don't repeat. So as far as we know, this is a function. And you would say that we have no repeating x values. Now it wants us to list the domain and the range. Remember that domain are your x values or your input values. So we have 1, 2, 3, and 4. And then we will list our range values, which are 4, 12, 19, and 26. If I look at the second table, we have some bad news bears. Look at that. We've got our x value of 1 repeats where we have a y value of 9 and a y value of 12. That does not match the definition of a function. Every x value must have only one y value. But these x values here, that 1 and that 1, have two different y values. That's bad. We can't have that. So we are going to say, no, this is not a function. And you can say a couple different things here. You can say an x value repeats, 1 repeats, something like that. I'm just going to put x value repeats. Now, when we list our domain and range, if you have a repeating domain value, you are not required to write it in the domain. So like if you look at the domain that I wrote down, I didn't do 1, 4, 1, 7. I just did 1, 4, and 7. I don't need to write the number 1 twice. My range will be 9, 6, 12, and 18. Range are just your y values. Okay, now when we take a look at number 3, notice that I do have 2 repeating x values, but the y values for those 2 repeating x values are the same. So if you end up with a scenario like this, you actually do have a function. And although we do have repeating x values, we technically don't. No repeating x values. So I'm going to write down here that these are the same. That's good. Okay. These are different. That's bad. Okay. All right. My domain will be 5, 6, and 7. And again, I'm not going to write the other 7 down. I don't need to. -3, -4, -5. Same here. I am not going to write down that repeating y value. All right, now determining if a mapping diagram is a function or not is going to kind of be the same thing that we just did. We're really focusing on the domain values, but in a mapping diagram, we are trying to ensure that each of these x values only has one arrow coming out of it. So if you look here, 1 only maps to 20, which is good. 3 only maps to 10. That's good. 5 only maps to 15. That's good. And then 7 only maps to 5. That's good. I technically do not have any repeating x values, so we would say yes, this is a function. We would say no repeating x values. And then the domain, we're going to list it as 1, 3, 5, and 7. And then our range values will be 5, 10, 15, and 20. Now when I come over here, do you guys see that 6 maps to both 0 and 2? That is bad, okay? That means that I have an x value with 2 different y values. I can't have that. So because of that right there, this is automatically not a function. Our domain is 6, 7, 8, 9. And our range is 0, 1, 2, 3. Ordered pairs are going to be very similar to what we just did. We're really only going to focus on the x values because that's what we care about. So I've got a 1, a 2, and a 3. Because all of those x values are different, this is a function. We have no repeating x's. Your domain will be what I have highlighted, 1, 2, 3. And then your range will be the unhighlighted numbers 2, 3, and 4. When I look over here at this set of ordered pairs, notice that the number 1 repeats in all 3 of the coordinates. That's bad. It's not a function. Your x value repeats. Sad face. All right, your domain value, the only domain value that you have is the number 1. You have 1, 1, 1, 2, 1, 3. It repeats itself 3 times. Your range value, however, is 1, 2, and 3. Okay, now this for sure is something that you did in middle school. We have to determine whether or not a graph represents a function, and we do this by using something called the vertical line test. And what the vertical line test says is we should be able to put a vertical line anywhere on our graph, and the vertical line and the graph itself can only touch in one place ever. And the reason that we use a vertical line is because that is what is representing our x values. X values are vertical values. They go up and down on your graph. Even though the x-axis is a horizontal line, your x values are vertical values. So we use a vertical line to ensure that we do not have any repeating x values. So I'm going to take a vertical line and I'm going to place it somewhere on my graph. And notice that your vertical line and your graph only cross once. I could put that vertical line anywhere on my graph, and anywhere I put it, notice that that vertical line will only ever touch your graph one time. So we would say, yes, this is a function. And then we would say that it passes the vertical line test. Vertical line test. Okay, when I look at number 2, I can put a vertical line anywhere on here, and no matter where I put it, notice that my vertical line will only ever hit my graph once. So we would say again, yes, this passes the vertical line test. What happens though if you have a vertical line? Well, vertical lines cannot pass the vertical line test because they are touching your graph an infinite number of times. That is bad. So this is not a function. And it's not a function. It fails the vertical line test. Vertical lines will not be functions. They can't be functions. Okay. Let's move on to this graph over here. These are a bunch of dots. If I put a line here, it's only going to touch that dot once, touch that dot once, touch that dot once. If I put a vertical line here, it touches two different coordinates, two different dots, okay? But I was just using one vertical line. So that right there is bad, okay? This is not a function. It fails the vertical line test. Okay, what we're going to do down here is we're going to use the ordered pairs to create a mapping, a table, a graph, and then we're going to determine if these relations over the same data, okay, represent a function. So the way that we do this is, that's supposed to be a comma. Whoopsie daisies, that's a comma right there, okay? What we have to do is we have to take all of our x values and put them as our input. So I'm going to start with that. -1, 0, 1, 2, and 2. Okay, now we have a problem right here. Do you guys see that those two coordinates have the same x value? When I make my mapping diagram specifically, I cannot put two number 2's in the diagram, in the mapping diagram. We're going to do -1, 0, 1, and 2. Do not write 2 twice. Then with the outputs, I've got a 2, a 2, a 3, a 4, and a 5. Again, I'm not going to list those 2's twice. I'm only going to list them once. So we've got a 2, a 3, a 4, and a 5. Now, the way that we do our mapping diagram is we list our inputs and then we list our outputs, and then we have to map them to their correct buddies. So, -1 is supposed to map to 2 based on this coordinate right here. 0 also maps to 2. Now, it's okay if you have repeating y values for different x values. You just can't have different y values for one specific x value. All right, 1, 3, 1 maps to 3. And then 2 maps to 4, but 2 also maps to 5. So that is how you do a mapping diagram, okay? You never repeat values within the ovals themselves. You show repeating values by having multiple lines coming out of your domain or range or whatever it is, okay? Okay, now that I have all of that, I am going to put those coordinates that I have at the top into the table. My inputs, remember, are my x values. You can put the 2 twice here because it's a table. And then -1 went to 2, 0 went to 2, 1 went to 3, 2 went to 4, and 2 also went to 5. Now, I'm going to do a copy. Let me copy you. A copy and a paste. And what okay, never mind. What I'm going to do is I'm going to use my input and my output values as coordinates, and I'm going to graph these, okay, on my table down here. -1, 2 is located there. 0, 2 is located there. 1, 3 is located there. 2, 4 is located there. And then 2, 5 is located there. Okay, now if you look, oops, come on. If you look, I've got these repeating x values everywhere, okay? That all of a sudden makes this not a function. And you would say that you have repeating x values. Sad day, okay? But all these that you are looking at right here, these are all different relations for the same set of data, okay? You can have a mapping diagram and a table and a graph and ordered pairs that all represent the same relationship between those x values and y values. So just know that that can happen. You're going to see this on your homework where you're given one set of data in one type of relation and you have to take that same data and put it in a different type of relation. So maybe going from a coordinate to a graph or a table to a mapping or something like that. But that's how you do it. Anyways, I know these notes seemed really long, but the content wasn't super difficult. But anyways, if you have any questions, please go see your teacher during their normally scheduled tutorial times, and I will see you in the next video.